Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 4, Lesson 8 on percent increase and decrease. Now, we've already worked with some percent increase and decrease problems. I think it was a couple lessons ago. But in this lesson, every single problem we work with, every single problem, is going to either be about a quantity increasing by a certain percent or a quantity decreasing by a certain percent. And on top of that, we're going to get some messy percents going on. So it's not going to always be increasing by 8%, decreasing by 5%. It could be increasing by 11.7% or decreasing by 4.2%. So we're going to be getting into a lot of that kind of messy percent work. Make sure that you've got your calculators handy. We're definitely going to be using those quite a bit. And let's get right into it in exercise number 1. Here we go. A small warm-up problem for review. Exercise number 1. Ruth works a job where she gets paid $750 per week. Next year, her pay will be increasing by 12% of what it currently is. Letter A, how much will Ruth's pay increase? Show the calculation you use to find your answer. All right, simple enough. Now, one thing that's a little bit weird in percent increase and percent decrease problems is that the whole is whatever you're starting with. Whatever you start with is sort of your denominator, if you will. It's the whole, okay? Now in this case, what we're starting with is $750, but we're going to be increasing it by 12%, specifically 12% of $750. All right, so actually figuring out what that is pretty easy, especially after all the work that we've done, right? We take that 12%, we change it into a decimal, 0.12. We multiply it by our 750. And again, although we could do that by hand, it's going to be quicker and more accurate to do it on the calculator. There's our 0.12 times 750. And we find that that ends up being $90. So 12% of 750 is $90. Now, letter B. What will Ruth's new weekly pay be after she receives the increase? Well, this is pretty simple, right? We know that the increase was $90. We know we started with $750 per week. We just have to add the 90 to the 750. I mean, we can do that with or without a calculator. That's pretty easy either way. That will give us $840. If the numbers were a lot messier, certainly do it on my calculator, but 750 plus 90, not too bad, 840. All right, so a simple idea, right? When we have a percent increase, we have some original amount. We find the percent of that amount, and then we add it on to get sort of our final answer. Let's now keep going with this idea. All right, let's do a percent decrease problem. Exercise number 2. A small pool starts with 13,500 gallons of water in it. That doesn't sound small to me, but trust me, it is. Curtis decides to drain the pool and notices that after 5 hours, the volume has decreased by 23%. Letter A, how many gallons has the volume decreased in 5 hours? Show your calculation. All right, and again, just like percent increase, what I want to think of the whole as being is what I'm starting with, all right? Again, I'm not talking about like the whole number of people, you know, in a room or anything like that. The whole is what we start with in percent increase and percent decrease problems. So if I want to find 23%, I'm finding 23% of the 13,500. Again, let's do this together. We'll have you do some other problems on your own. It's simple enough, right? I take my 23% and I convert it into a decimal, 0.23. I'm going to multiply that by 13,500. Again, on my calculator, that's going to make for just some button pushing, 0.23 times 13,500. Just got to watch my calculator entry there. And I'll find 3,105 gallons, right, of decrease. Now, letter B, very similar to our letter B in the last problem, what's the volume of the pool after 5 hours? Well, that 3,105 gallons let me put that, is what it went down, right? That's not the volume in the pool after 5 hours. That's how much left the pool after 5 hours. To actually figure out how much is still in there is easy enough. I want to do kind of what I did before. I'm going to take my original amount, and instead of now adding this to it, I'm going to subtract it, right? And that makes sense because we're decreasing, right? So we have 13,500 minus 3,100, whoops, I almost said 150, but it's 3,105. Let me just check that. Yes, it is. So again, easy enough to do by hand, but also quicker to do on the calculator. Gives me 10,395 gallons in the pool after those 5 hours. All right? So percent increase and percent decrease problems really are no more challenging than what we've done in the past. The big difference is that often, after we've calculated the percent of whatever we started with, we either have to add it onto what we started with for percent increase, or we have to subtract it from what we started with for percent decrease. Hard to say. Anyway, let's keep moving on and getting some more work with this. Now, in percent increase and decrease problems, the whole is always considered the original amount. Now you might think, whatever, that seems easy enough, but sometimes it can be confusing. Let's take a look at exercise number 3. Answer each of the following. Show the calculations that lead to your answers. Letter A. Linden Middle School has 480 students. The number of students is increasing by 5% next year. How many students will there be? All right, well, what I'd like you to do is pause the video now and see how many students will be at Linden Middle School next year if they started with 480 students and the population is increasing by 5%. All right, well, the first thing we're going to do is find 5% of that 480. And that is, again, going to be pretty easy because I'm just going to take my decimal version of the percent. Be careful there, that's 0.05, not 0.5. We're going to multiply it by 480. All right, let's figure out what that is with our calculator. So we'll have 0.05 times 480. All right, and that gives me 24. And boy, I tell you, it's critical now to realize that that's not our answer. That'd be really, really strange, right, to have the number of students go from 480 down to 24. I guess it could, but keep in mind, that's actually the increase in the number of students. So our student population is going to go from 480 up by 24. So that's easy enough, right? The population of students next year is now going to be 480 plus 24. I'm going to do that one without the calculator, and that's going to be 504 students. So hopefully you got that one. All right. Let's take a look at letter B. The price of a sweater is marked 14% off its original price. If its original price is $85, what is its sale price? Now notice, in both of these two problems, we're not really, phrasing them exactly like we have seen the other problems. But we have to realize, 14% off its original price. That means we're going to take the original price, which is $85. We're going to find 14% of 85, and then we're going to decrease the $85 by that amount. So I'd like you to pause the video now and try to figure out the sales price of the sweater after 14% was taken off. All right, let's do it. First things first, let's find 14% of $85. Again, easy enough. Using our decimal multiplication, 0.14 times 85. Bring out our calculator. 0.14 times 85 gives us 11.9, and I'm going to tack a 0 on. All right, now again, keep emphasizing this. This is not the sales price. This is not our final answer, right? That is how much the price went down. All right, if we actually want to figure out what the sales price is, we're now going to take our $85 and we're going to subtract off $11.90. So again, easy enough. We'll do 85 minus 11.90. I know that this is very doable without a calculator, but let's speed ourselves up. 85 minus 11.9. I'll tack the 0 on, and I will find a sales price of $73.10. Right. And that's, by the way, exceptionally common, right? You see that all the time, especially around the holidays and other things like that. You'll see, the sale is marking everything down by 15%, or all items in this store are going to be marked down by 20% or 25% or 32% or whatever, right? And then you see this price as you're looking at it, but that's not the price you're paying. You're actually going to pay less than that. The question is, can you figure out how much less? All right, so let's keep going. Now, in all of these problems so far, what we've been doing is we've been, given the original amount and given the percent that it's either increasing or decreasing, and then, using that. Now let's again go to that flip side, the other side of the coin, and let's take a look at and see if we can calculate the percent increase and the percent decrease that's going on, right? Let's take a look. Exercise number 4. Antonio is making $24 per hour at his job. He's getting a raise of $3 per hour. What percent of his original salary is Antonio getting in this raise? Show the calculation you use to find your answer. All right, now again, this is really important, right? This is like the part, the percent that the part represents. But again, the whole is always what you start with, always what you start with, always what you start with. So what we want to know is what fraction or what percent the 3 out of 24 represents. So the part in this case is the 3, the total is the 24. All right, now let's do what we've done in previous lessons. Let's do 3 divided by 24, and we're going to get 0.125. All right, so this fraction and this decimal represent the portion of the original salary that the raise represents. As a percent then, that would then be 12.5%. So Antonio got a 12.5% raise. Now, that problem is actually fairly easy because, it's sort of, well, what percent does 3 represent compared to a total of 24? Let's take a look at letter B, though. Lacey's salary increased from $13 to $17 per hour. What percent did her salary increase round to the nearest tenth of a percent? Now, this can be much harder because a lot of students will want to say, let me do 13 divided by 17 or 17 divided by 13, both of which would be wrong. All right? What you really have to do is say the following. Well, we had $17 minus $13, and that was a $4 raise. All right? So if you just wanted to know, well, what was Lacey's raise? Well, her raise was a $4 per hour raise, but we want to know the percent of her raise. So the question is, should I take the 4 and divide it by 13, or should I take the 4 and divide it by 17? And the answer is, I should divide it by the 13. The whole should always be considered what you begin with, all right? The raise itself was the difference between these two, and you're going to see that a lot in the next few problems. We're going to be doing some subtraction and then taking the answer to that subtraction and dividing it by what we started with. Plain fact is, again, what we're trying to figure out is this fraction as a percent, right? So what does 4 represent as a fraction of what we started with, which was 13? Now, again, talk about some ugly math, dividing by 13. So here we'll have 4 divided by 13, all right, and that's 0.30769, etc. If I were to then multiply this by 100, just so that I can really see the percent just sitting in front of me, right, given that it's a little messy, that would be 30.769, etc. And now let's step away from this for just a minute, right? We wanted it to the nearest tenth of a percent. In the last lesson on messy percentages, we were oftentimes rounding to the nearest whole percent. Here I want it to the nearest tenth of a percent. So 30.7, right? And then I look at the 6. That 6 means I should bump the 7 up to an 8, as if that wasn't confusing sounding. So we'll have 30.8%. 30.8%. All right? And again, the thing that's tricky about this is we have to first just figure out what the raise was, right? Oh, it increased by $4. And then what does that $4 represent as a proportion or fraction or percent of the original? Let's keep looking at that idea. Hey, that was kind of cool. In the next problem. Here we go. When forming the percent fraction or ratio, always make sure to have the original amount in the denominator, as if I haven't mentioned that enough. Exercise number 5. For each of the following scenarios, find the percent increase or percent decrease. Round percentages to the nearest tenth of a percent when necessary. Letter A, Gloria's car payment increased from $240 per month to $275 per month. What was the percent increase? Okay, great. So before you ever do percent increase and percent decrease, the first thing you really have to figure out is just how much the thing, whatever the thing is, in this case it's a car payment, how much the payment increased. So the actual increase itself, not the percent increase, but the increase itself is just given by my 275 minus 240, or $35, right? So Gloria's car payment went up $35. Now what I want to do is I want to compare that $35 to the original amount that she started with. And what she started with was a payment of $240. So I'm now going to just have 35 out of 240. There's my, my fraction or my percent ratio. I'm now going to do 35 divided by 240. That is going to give me 0.1485. Whoops, nope, 58, not 85. 58333, etc. Nice repeating decimal there, right? And that is going to be 14.6%, right? 14.6%. Let me see if I can get this to be a little bit bigger. Ah, there we go. Fantastic. All right, let's take a look at a percent decrease problem in letter B. The population of a small town decreased from 2,340 people to 1,835 people. What percent decrease did this represent? Now again, the first thing I need to do is just figure out how much did it decrease? How much did it go down? So the actual decrease itself, oh, my board's not being happy with me. There we go. The actual decrease itself will be 2,340 minus 1,835. Again, real quick, let's do that on the calculator. Now that's a nice size, 2,340 minus 1,835 gives me 505, right? So that's the actual decrease in population. Now what I need to do is figure out what percent that 505 represents out of what I began with. So it's not always like the smaller number, right? It's out of what I began with. I began with 2,340, so we now have 505 divided by 2,000. 2,340. Let's do that division on the calculator. 505 divided by 2,340. And that's going to be 0.2158, etc. And as a percent, that's going to be 21.6% rounded to the nearest tenth. All right, easy enough. Now we've got two more problems on here. What I'd like you to do is pause the video now, try to work through problem C and problem D, and then we'll go through them. Take a little bit of time. All right, letter C. Attendance at a baseball game went from 458 one week to 605 the next. What was the percent increase in attendance? Awesome. So just like the other problems, what we're going to need to do is first just figure out how much did the attendance go up, right? What was the actual increase, not the percent increase? So the actual increase is 605 minus 458. Let's do that. So we've got 605 minus 458 gives me 147. So the population went up by 147 people. All right, now I need to figure out what that 147 represents as a percentage of what I started with, the 458. So I'm going to do 147 divided by 458. And let's see what we get there. 147 divided by 458. All right, that's 0.32096, etc. And we can now say that that's 32.1%. All right, a 32.1% increase in attendance. That's a big percent increase. All right, let's take a look at that last one. All right, letter D. The amount of money that Blake owed his credit card dropped from $370 to $125. This represents a decrease of what percent? All right, so again, importantly, we need to figure out how much the overall decrease was to begin with. So this is simple enough. We're going to go 370 minus 125. So just tell us how much the actual thing decreased. So 370 minus 125. So he decreased his debt by $245. We're now going to find out what that 245 represents out of the 370 by doing the division. We started with 370. So we'll do 245 divided by 370 gives me 0.6621, etc. And that's equal to 66.2%. All right. What makes these problems very tricky for students is they often know with percent, hey, you're supposed to take some part and divide it by a total. What makes things hard with percent increase and percent decrease, especially in this particular problem, is that we're given two numbers, but we're not dividing those two numbers. We actually take those two numbers, like in this percent increase problem, and we subtract them to find the actual increase, or we subtract them to find the actual decrease. And then the real question is, what does that increase or that decrease represent as a percent of what we started with? Here we started with 458, so we increased by 147 out of 458, a 32.1% increase. On the other hand, here, that debt was decreased by $245. That 245 is compared to what we started with, 370, to see that we went down by 66.2%. All right, let's wrap this up. Percent increase and percent decrease are two of the most important applications of percent. And we'll see some more applications in the coming lessons, all right? But these things are huge. Oftentimes you're told, the world's population is increasing by 3.5% per year, right? Or, the debt of, this particular company has been decreasing at 2% per, every 5 years or something like that. Or simply, hey, my salary went up from, $8 an hour to $10 an hour. What percent increase did I actually get? Oh, well, I got $2 of increase out of $8. I got a 25% increase in my pay. So, being able to deal with percent increase and percent decrease are very, very important ideas. We'll get more work with them in coming lessons. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. Until next time, keep thinking and keep solving problems.